But in 1.2, this is talking about variables and type of data. So in objective 3, we want to identify types of data. And one of them is a variable, is a characteristic or an attribute that can assume different values. So meaning a variable can represent different numbers. It can represent measurement, a total of group. It can represent an attribute, meaning they're blonde, brown-headed, black-headed, they're male, they're female, they're 12, they're 14, they're 16, whatever the concept is. But the variable can be a characteristic or an attribute and can be different values. So variables may be categorical. All right, so this is a big one right here, categorical, or also called qualitative variables, right? Qualitative is comes from the root word quality, which are just characteristics. These are typically not a number, typically not a number, but can be. So let's take, for example, a zip code. A zip code is a number, but is a location, it's a characteristic. So just kind of watch out for that. But qualitative variables are typically not um, a number in itself, but it can be. A phone number is another one. That's a characteristic that is not an actual value. Or they may be numerical. That's your next biggest one. And these are called quantitative variables. All right. So in quantitative, these are typically numbers. So maybe there are 20 headed people. Maybe we're doing measurements. So maybe we're looking at 65 inches. Maybe we're looking at the circumference, and it's, the circumference is 34 inches or 30. Maybe we're looking at distance from a building. So maybe it's 34 feet. So, or maybe it's just quantity of something. So maybe there is 50 people that are the age of 12 in a freshman class or something like that. Or maybe there are, 150 19-year-olds taking a course. Whatever that situation might be, it's typically a number. Right. Now, eye color, gender, location, and satisfaction rankings, like you agree, strongly disagree. Those are your satisfaction rankings, are examples of qualitative variables. Temperature, age, number of pets owned by a family, weights are all examples of quantitative variables. So notice kind of the difference here. These are all going to be, and then watch out for the satisfaction rating, because a lot of times you can do 1 through 5. Those are numbers, but those numbers represent a ranking. This all deals with numbers. So this is characteristics. These are numbers. So temperature, age, number of pets, weights, things like that. All right. So out of those situation there, when we are talking about quantitative variables, our numerical can be ranked or ordered. Quantitative variables can be classified into two groups, discrete and continuous. This basically means you can count. So if we have how many people are over the age of 50, we're going to get a whole number. We can count them: 1, 2, 3, 4. Continuous are going to have what we have decimals, or perhaps maybe even fractions. Continuous data is could be the probability that you get a green marble 42 different times, right? It's going to be a continuous function over however many options there are. Continuous data could also be basically it could be an infinite many things in the decimal world. So maybe even the measurement of a tree trunk, right? It ranges from maybe 30 to 34 inches. So all those decimals in between are used as well. So that would be what we call continuous data. All right, so a discrete quantitative variable assumes values that can be counted, such as the number of people in a household, the number of eggs needed for a recipe, or the number of chairs at a table. A continuous quantitative variable can assume an infinite number of values in an interval between any two specific values, such as temperature, amount of baking soda needed for a recipe, or a weight of a book. These things can change by the decimal. So it could be, 39.4 degrees Fahrenheit, or it could be 39.328 Fahrenheit. And the decimals there are unlimited, right? It's depending on how specific they want to get. So those are continuous data. I can't count temperature because it can change even into the fractions. Quantitative variables are obtained by measuring and can include fractions and decimals. So there you go right there. So we can see that continuous variables may be recorded as the nearest inch, nearest ounce, or nearest unit of measurement. So values could have taken on any value in an interval from half a unit below the recorded value up to, but not including, half of a unit above the recorded value. So for instance, 4 feet may actually mean any length from 3.5 feet to 4.5 feet, including 4.5 itself. Not including 4.5. So basically 3.5 all the way up to 4.5, but not including. So a value recorded at 8.3 may be any value of. So what we do is we go basically 5 points past that decimal on top and bottom. So here, if it's 8.3, if I add another 5 at the end there, that's going to now give me 8.35. But if I added a 0.05 to this, I also have to subtract a 0.052. So this 8.3 could range anywhere between 8.25 but not all the way up to, but not including 8.35. We don't know how much the reader or the person doing the data rounded to get that 8.3. So we have to assume it could fall under any one of these type of numbers. All righty. So let's get into then objective 4, which is identifying the level of measurements for each variable. So qualitative and quantitative variables can also be classified or categorized using measurement scales. The 4 common types of scales for classifying variable are, and these are very important. You need to know that you have what we call nomial, ordinal, interval, and ratio. All right, so the lowest level of measurement is nomial, classifying qualitative variables in non-overlapping categories that cannot be ordered or ranked. Right? So you cannot rank this, you cannot order this. So a couple of things to kind of go through that. We have examples right here. Examples that are labeled for which there is no meaningful order or rank, but it is a qualitative data. So it does describe something. You're not able to rank it. So like zip codes, that's a number. But again, it is a characteristic, and you can't rank zip codes. You can't rank addresses, but it's characteristic. It's a descriptive factor. Social security number describes somebody, but you don't rank that. Gender, male or female, is not ranked. It just describes the person. Ethnicity, white, black, Chinese, doesn't matter. It is a descriptive character, cannot be ranked or ordered. Company corporation names, all the different companies out there cannot be ranked. ISBN number for your computer is not ranked. Tracking numbers for packages are not ranked. Television channels are not ranked. These are just descriptive characteristics, but not actual ranking or order to this. So these are all examples of nomial data. The second level of measurement is called ordinal. It still characterizes something, and it's still a qualitative data, so typically not numbers, but it breaks the variables into categories that can be put in order or assigned a rank. Right? Examples of these basically can be put in a neutral order, but precise differences between the values cannot be measured. So it doesn't have values, it just has a ordered to it. So some examples of that are a satisfaction rating, right? Superior, average, good, right? This goes from a 1 to 3 situation here. It has a characteristic, but has an order to it. If it's superior, it's number one. If it's poor, maybe it's number three, or vice versa. Maybe it goes 3 to 1. Football team rankings. You're in first, you're in second, you're in third. Now it's ordinal because now we have a place for you. Some clothing size, small, medium, large, has a ranking. Pain level, you have a pain level rating from 0 to 10. That is a rank. Ranking preference for vacation sites, rank from 1 to 10. So if it can be in a specific order and be ranked at different levels by one person may not have the same meaning of another person who selects the same ranking. So therefore, it could be ranked, but their pain level of 2 might not be the same pain level as my 2 or your 2 or anything like that. All right. If we kind of keep going through this, the third level of measurement is interval. This is our first quantitative variable. So nomial and ordinal are qualitative, and then interval is a quantitative because it has an actual value. These can be ranked or ordered, has precise differences between units of measurements, but has no meaningful zero, meaning the zero doesn't it doesn't like best way to put it is the placement of zero on a measuring scale is arbitrary. So it just doesn't have it has zero, but it has like it's not the absence of something. So zero needs to represent that there's just nothing there. So for example, temperature, it has zero, but zero is not the absence of heat or cold. It's just a 0 degree marker. We have negative temperature degrees as well. So things to kind of pay attention there. Like, for example, Kelvin. If you're familiar with Kelvin, zero is the absence of temperature. It's the coldest moment of time and actually supposedly supposed to freeze time. That right there would not be an interval because it does have a meaningful zero. So again, zero just means that it needs to have a it's like the absolute. You can't go any lower than zero. So if you can go lower than zero, so you basically can go from the negatives to the positives, then we call it interval. If you can't go past zero, and so you don't have any negative values, now it's going to be what we call a ratio. Right. So again, calendar years, depending if you're looking at AD, BC, time of day, but not the length of time, doesn't have an absolute zero as well. Because I can go 20 minutes ago, so that's -20 now, right? Scales such as standardized scale of a politician orientation that are constructed to have equal intervals, things like that. All right. The fourth and highest level of measurement is a ratio, which has the same characteristics as interval and has a true zero, a zero with meaning. So weights can be ordered ascending or descending and has a precise difference. For instance, 200 pounds is 90 pounds heavier than 110 pounds. So it has a meaning there. If I was to have 0 pounds, then I would have the absence of pounds. I don't have negative weight. So 0 pounds does have a true meaning. So therefore, it is a ratio. The way I like to remember this is there's an O in ratio. So ratio has a true zero and cannot go any further than that. Some more examples of this. Again, can be ranked order, has precise difference between values, and has a true zero. Ratios make sense. For instance, 12 miles is twice as far as 6 miles, right? That is a interval. Distance, so on a scale, kilometers, miles, etc. I can't go backwards. So there's a distance. Volume doesn't have negative volume. If it's zero, it's an absence of volume. Number of books in a library, I can't have negative books. I can either have no books or some books. A GPA, if you have a zero, that means you don't have a grade at all, but I can't give you negatives. Years of work experience, I can have 0 years. I just can't have negative years. Household size, I can have 0 people living in it, but I can't have negative people living in it. A weight of recyclables discarded each week. I can have 0 pounds of recyclable material, but I can't have negative that. So things to think about. So here's some examples. Let's look at it. I want you to first describe if it's qualitative or quantitative, and then which of the four would it be? Nomial, ordinal, interval, or ratio. Typically, if this was a face-to-face class, I would give you some time to work them out. But since it's not, let's kind of go through them. You can pause it and try to figure them out yourself and then see if you're correct. All right, for starters, eye color has no number in it, so I know it is a qualitative data. Eye color, I have to ask myself, can this be put in an order or rank? And the answer to that is no. So if it cannot, it must be a nomial. It still describes something, but just can't be ranked. Number of years employed by a company. That word number tells me it's going to be a number, so I'm going to go with quantitative. Now, number of years employed, is this going to be something where it has an absolute zero or an absence of zero? So number of years employed, I can have 0 years of employed, but I cannot have negative. So therefore, this would be a ratio. Ranking of a tennis player, all right? Does not have numbers. It's just a ranking. So this would be a qualitative, and it's a ranking, so it is put in a order. So this means it is ordinal. The year you graduated from high school, this is an actual number. So that would mean that that is quantitative. And again, the year you graduated from high school, technically, because of the way school works, is we do have AD and BC. So there is a zero, so I can go to the AD if that's when you graduated high school. So this is actually what we considered a interval. It does not have a true zero since you have BC and AD. All right, so IQ, that's an actual number. So that's going to be quantitative. And then IQ doesn't have, I can't have a negative IQ. I can have down to zero. I just can't, I don't even think you can actually go to zero, to be honest with you. No, I think I guess you can if you just don't take the test. So this would be a ratio. It has an absolute zero. Time elapsed, right? Again, this is numbers, so this is going to be quantitative. And again, time elapsed. I had a starting spot, and then it went over time, but then I can also go back in time. Maybe it was 20 minutes before we started, 20 minutes after I started. So this, oh, sorry, I lied. Time elapsed. I can either have 0 time elapsed or I can have 2 minutes elapsed, but I cannot have negative time elapsed. So this would be a ratio because again, it has an absolute zero. I cannot have negative time. Grades A, B, C, D, E, F. All right, these are letters, not really numbers. This tells me this is qualitative. And because there's a ranking to it, A, B, C, D, F, this tells me it is ordinal. Next part, street address. This is describing something, but doesn't have specific values. So this is going to be, even though you do have like 111 or 222 or 503 or whatever the situation might be, this is going to be qualitative because again, it's going to be describing something, not giving it a number itself. Because I cannot put street addresses in a certain rank, saying that one's better than the other, this is going to be a nomial. Items on a menu. I can actually count the number of items on a menu. So therefore, oh, I guess we need to specifically look at that. It doesn't say number. It just says items on a menu. So that could be chicken, beef, fish, whatever that is. But I'm not asking the number of items. So since I'm has the absence of numbers, I'm just looking at the items. This will still be qualitative because I'm describing different foods. And I cannot put foods in a specific order unless I was ranking them. So therefore, this would be a nomial as well. Next one, number of pasta dishes on the menu. Now that it has that number there, now we can say it is quantitative. And because it's saying number of pasta dishes, I cannot have negative pasta dishes. I can have zero or more than that. So therefore, this will be a ratio. The price of menu items. This right here again has a specific number. So this is quantitative. But when looking at the price of menus, there's no company in this world that will pay you to take some food items, right? You can have a price of zero, or maybe they have free items, but they will not pay you as well. So you can have free, but you never have negative price items. So this again will be a ratio because it has a defined zero. All right, so that's pretty much all the way through 1, 2. Let's get into 1, 3.